Good evening, everyone. We have a very tight schedule tonight, so we need to get going. We have a lot of information to cover, and we also want to get plenty of debate in. So I'm Stephen Simons. Welcome to the launch of our carbon capture and storage paper from the IChemE EEnergy Centre. I'm chairman of the board of the Energy Centre, so it's a great pleasure for me to be here tonight. And I'd like to welcome all our listeners over the internet and the webinar. I think we have something like 180 people registered to follow us on the internet. Hence, microphones are really for their benefit, so they can hear what's going on. Okay, so as I said, very tight schedule. I'm going to be chairing the evening and keeping everybody, hopefully, to time. Okay, so I just need to show you that the report is available to download from the IChemE website if you're interested. You've all got copies on the chairs. Those of you in London, those of you that are joining us on the internet, you can see that address there, icheme.org/2018 CCS. I've got just a few minutes to just introduce you to the IChemE EEnergy Centre. And again, the contact details for the centre are shown on this slide. Some of you would have seen these before and know all about the Energy Centre. We formed and were launched in March 2015. So we are 3 years old now, and we have been discussing or reviewing what we've been doing in those first 3 years. It's been quite an exciting time. We've achieved quite a lot, and we're very proud of this paper that's being launched today as one of our key outputs. And it's really providing an evidence-based chemical engineering perspective on global energy challenges and giving a voice to the chemical engineering community, to that evidence base and to policymakers. And hence this paper tonight is really aimed at helping policymakers in achieving the goals that we're setting out to achieve. A little bit about the structure. So we have a board. The board is made up of representatives across the energy sectors and across and has a wide geographic reach. So we have members on the board from South Africa, from Australia, from Singapore, Malaysia, and of course the UK. So all the key areas that we have IChemE membership, and all the energy related SIGs are represented on the board as well. To help us achieve our aims, we've set up a leadership forum, and these are experts like yourselves in the room who wish to contribute to the tasks that we set ourselves, and Jeff will show you who has contributed in that way to this very paper. And then we have a very active future energy leaders group of young people who may be fresh out of university or have been just less than 5 years in industry, and have potential to be leaders in the energy field, and they've been fantastic and really active, and have also contributed to this paper. The focus areas came out of surveys that we have completed with the IChemE membership, and over the last 3 years we've been really looking at how we focus on our activities, and we've come up with 2 overarching themes that we're now focusing on: the energy and resource efficiency aspects, and we are chemical engineers, so it's very important for us to think about the future of oil and gas, and that actually has been one of our most popular themes in terms of the number of workshops that we've held all over the world, and the different kind of views that we've been getting from the membership about what the future of oil and gas may look like, particularly for our members. And we have 4 subtopics, of which carbon capture, storage and utilisation is one, energy storage and grid management, sustainable bioenergy, and nuclear energy. So you can see how all the energy related SIGs can contribute to those areas. And these areas, there's no particular priority order there, but these all came out of the survey that we did with the IChemE membership on what priorities we should look at. And as I said, we've achieved an awful lot in the first 3 years. We've had many workshops, not just in the UK, but certainly in Malaysia, Australia and Singapore. We've attended and spoken at major conferences, particularly the COP climate change meetings, and particularly the COP21, which I'll mention in a minute, World Engineering Summit in Singapore, and of course the big World Congress of Chemical Engineering that was in Spain last year in Barcelona. And the future energy leaders have been very active too. For instance, they had a stall and some very interesting energy forecasting modelling at New Scientist Live last year, and I think they're going to do something similar this year. We're producing position papers, which tonight's paper is one, and we're also involved in other policy developments. We've commented on the UK government's industrial strategy, and we've joined up with Future Climate Engineering Solutions, which is a group, multi-institution group, and we're leading, the IChemE Energy Centre is leading on the development of the UK Energy 2050 plan. So that's something we're working on at the moment. And other types of activity we're involved in is putting together case studies of best practice that we can put on the website and show the world and our own community what chemical engineers are getting up to, particularly in energy and resource efficiency, which is something that we're currently pulling together, some really nice case studies. So I mentioned COP21, and I was lucky enough to represent the Energy Centre at that very important meeting. Of course, I wasn't involved with the negotiations, but if you've ever been to one of these COP meetings, there's plenty going on the periphery of the negotiations, and we were part of what they call a side event, which was looking at and debating whether we had the technologies now to be able to meet the target set by the Paris Agreement, because at that time we already knew that 1.5 degrees C, limiting average temperature rise to 1.5 degrees, was already on the table in the negotiating room. And you can see from the article that was published in the TCE that we argued, or I argued, that we do have the technologies now, but what we need to do is get on with it, and we need to have a systems approach to that, and chemical engineers are very well placed to provide leadership in this area. And I mention that because I just want to link what's tonight with a scenario that came out, I think it was last week or the week before, just very recent, from Shell. Shell have been looking at various scenarios since 2013, so before COP21, on how we could get to a net zero emission energy system by the end of the century. And they produced these scenarios. One was called Mountain and one was called Ocean. But of course that doesn't meet the Paris Agreement target, because it needs to be before the end of the century, 2050, 2070. So they've now produced a new scenario, and they've called it Sky, and it's just been published, and you can get it from their website, which is about how we could achieve net zero emissions by 2070. And what's interesting is that CCS plays an absolutely core part of that scenario. Without CCS it doesn't work, and you can see in these diagrams how it's not only CCS, but it's CCS in combination with a biofuels system, which draws down, combined with CCS, draws down CO2 emissions from the atmosphere into the geological storage. And in that way, by 2070, you can achieve the net zero emissions, and you're heading towards the target of stabilising temperature rise below 2 degrees. And this scenario points out things like that we show CCS on not just on fossil fuel energy generation, but also chemical industry, cement industry. We need to combine it with biofuels, and these are all points that Jeff and his colleagues have raised in the paper. But the scenario is just about what could come about. Our paper is about what we should be doing to make it come about. So there are recommendations in the paper to policymakers and to us as chemical engineers about how we can actually deliver this type of scenario. And the Sky scenario says at the beginning that it's all technically possible. It's just a matter of thinking about the system and developing the pathway. So I think it's a really nice link to our paper because it supports a lot of what Jeff and his colleagues have come up with. As I said, our policy, our paper is all about policies we need to get it going. So I'd like to invite Jeff to come to the podium to summarise and introduce his paper.
Thanks very much, Steph. And good evening, ladies and gentlemen, both here in the room and those of you online, wherever you are in the world. Thanks very much for attending this launch of our green paper, which has a rather long title there. But it's concerned with identifying the challenges, technical, economic and political, and the opportunities for delivering carbon capture and storage at scale. And having established whether CCS is a good thing to do and looking at the evidence of that, which I'll say a little about, which is very convincing, the report really aims to do two things. The first is to identify the barriers to widespread, large-scale global deployment of CCS and to make evidence-based recommendations on how those barriers may overcome and all new enablers put in place to make that happen. So if you like, that's the external facing part of this paper. And then there's also an internal intention because it's a green paper to stimulate discussion and debate amongst our members and the wider engineering community about the role that CCS can play in the future decarbonisation of our energy systems. And also to, alongside that, identify where chemical engineers can, should and will play a role to make that happen. Now, IChemE is a global organisation, and so what we try to do in this paper is to present a global perspective, but that draws quite heavily to some extent on evidence from places where CCS has had the greatest profile. So that will be particularly the US and Canada, here in the UK, where we've had several, you may say, failed attempts to get it off the ground, and particularly in Australia as well. So I'd particularly like to thank the members of the task group. There were 27 members of our leadership forum that took place, some people that we brought in, co-opted from outside as well, to help us to put together this paper. And I'd like to thank them for all their commitment and hard work in doing that. I'm not going to go through them all individually, but you'll find them on the penultimate page of the report. And I'd also like to thank Geoffrey Maitland, who, as policy officer of the Energy Centre, was very instrumental in supporting very strongly the group. And also Alana Collis, sitting here, who was responsible for much of the final editing and production of the report that you have in your hands. And I'd also like to thank my Brie sitting in the audience here from Imperial College London, who collaborated with me in preparing some presentations based on this report and some of whose material I'm going to use tonight. So, first of all, just the case for CCS. We see here a whole range of these integrated assessment models predicting how CO2 emissions are going to vary with time according to different scenarios that are going to meet at the top there. The red is essentially business as usual, and the bottom blue line are scenarios that attempt to meet the 1.5 to 2 degrees scenarios that Paris reached global agreement on. So Paris was the beginning, not the end. Those are the aspirations. We're talking about how do you achieve that. And if you look at those models, you see that several conclusions come from that, that all the models that include CCS to reach this target are lower cost scenarios by up to 40%. So CCS lies on the lowest cost pathways to reaching the Paris targets. And indeed, without CCS, less than 50% of those models fail to reach that target. And those that do are more expensive. And then the final point I'd make there, if you see at the bottom, in the later parts of this century, in order to meet the 1.5 target, we've got to go carbon negative. We've got to actually take CO2 out of the atmosphere. And there are relatively few technologies that can do that. People are looking at air capture, which currently is very expensive and low volume. BECCS bioenergy with CCS, which makes use of natural photosynthesis to take CO2 out into plants and biomass, and then uses this biomass, as Steph was pointing out in the sky scenario, enables you to actually take CO2 out of the atmosphere very efficiently and high volume. And the point I'd make here is that if we're to have BECCS in the second half of this century, then we need to have a fully global and integrated CCS infrastructure in place for conventional CCS in order to make that happen. The area between the red curve and the blue curve there, that gives you the amount of CO2 that we have to take out of the system between now and 2050 in order to meet these targets. And that amounts to about 800 gigatons of CO2. And without going into the detail, about 50% of that we can probably do by energy efficiency and fuel switching to low or zero carbon fuels. About 30% with a combination of renewables and nuclear. But that still leaves us with about 20% that we need to achieve by continuing to use fossil fuels, but taking the carbon out using carbon capture and storage. That amounts to about 10 gigatons per annum by 2050. So let's just look at the scale of that challenge. Carbon capture and storage has been going quite a long time. It's not a new technology, despite what some people think. And in 1972, there was a plant there taking out about 0.5 megaton per annum. In 1996, in Norway, Sleipner, driven by the carbon tax in Norway, is still going strong at about 1 megaton of, per annum of CO2. But 20 years later, we only have about 20 commercial scale, that is greater than half a megaton of CO2 per annum. And these projects have an average capacity of about 2 megatons per annum and a total capacity of 31 megatons per annum. And if you compare that with that target of 10 gigatons per annum we need to reach by 2050, you can see that the challenge is enormous in terms of the number of projects and the scale they have to be at. Say if they're about 5 megatons, then you need about 2,000 projects. So we've got to move rapidly and quickly to large scale, and that's why the emphasis has before been very much, if you're going to do carbon capture and storage, you've got to do it on this sort of scale and to do it very quickly. So I'm just going to summarize briefly 7 points about making CCS a commercial reality, the detail of which is in the report. The first point is that the barriers to introducing CCS very quickly at large scale are not technical. There's plenty of technology there. This is a technology pipeline going from TRL1 to TRL9, and there's enough TRL9 technologies at the capture, transportation and storage level to implement CO2 now, as evidenced by the fact that although we don't have many, we have these 20 or so large-scale commercial projects or semi-commercial projects in some cases that are capturing up to 8 megatons per annum, the largest. There is technology in the pipeline, and that will come through over the next few decades. And one of the challenges of CO2 is the expensive when we've got to reduce the cost. The initial cost reductions will not come from introduction of new technology, but there'll be a second wave by which we can reduce the cost by introducing new capture, particularly new capture and compression or avoiding compression technologies to bring the cost down. And then what are the conditions we need, therefore, to make this transformation? Well, the first thing is to provide a route to monetize stored CO2. CCS, as we know, adds cost. In power, it's the so-called energy penalty. And these costs vary according to the technology and the source of the CO2, but they're of order $50 per tonne of CO2. Now, those costs can be recouped by monetizing CO2 if, for instance, you can carry out EOR and EGR by injection of the CO2 and have some revenue generation from the enhanced oil or gas recovered, and projects in the States are doing that, or where there's a carbon price, as in Norway, or other financial incentive, such as emissions trading system that's effective, or carbon tax credits like the 45Q system that's now in place in the States that pays people to bury CO2, then again you can monetize the buried CO2. However, those mechanisms are not available in a lot of countries, and we have to look at what other financial incentives can be provided. The next thing to recognize is that, in fact, the value of CO2, although there's been a lot of emphasis on power generation, is much broader than that. It can decarbonize industrial processes and hydrocarbon production, and in many cases is certainly the lowest cost way to do that, but in some ways is the only way that we're going to decarbonize those processes. And remember that industrial emissions represent over 20% of the total anthropogenic CO2 release, and they're very important and shouldn't be ignored. CCS, as I've said, is usually the most cost-effective option to decarbonize those, and where you are generating CO2 as part of the process, as in cement and steel, it's the only way. So one of our recommendations is that CCS, combined with process energy efficiency, an optimization of that, for both existing and new build plants, should be a priority for industry and for chemical engineers as core to their agenda, and that we recommended a rather ambitious decarbonisation of that sector by 2030, which is doable but requires swift movement. And then if we take production of hydrogen, now hydrogen is seen as a leading contender for decarbonisation of heating, along with perhaps ground source heat pumps, which are more expensive, but CCS is required to remove CO2. If you're going to produce hydrogen from fossil fuels, you could have if you've got cheap renewable electricity, you could use electrolysis to get that, but to get the volumes that we need to decarbonise heating globally, then we need to use things like steam methane reforming to produce the hydrogen, take the CO2 out and sequester it. And that could deliver low carbon hydrogen at the volumes and costs we require. We could also use the hydrogen, of course, for decarbonised transport. And there are some examples in the UK at the moment, the Leeds project and the Cadence Liverpool-Manchester projects, which are attempting to do just that, to generate hydrogen with CCS for heating. Now, in the first phase of deployment, the main way that we're going to reduce the costs of CCS is not by doing small-scale, medium-scale demonstration projects, but by having multi-plant, large-scale deployment, where we can take advantage of the economies of scale and the major cost reductions you get in any process deployment, with the cost reduction and efficiency improvement through the learnings as you go from the first to the end plant. Those can bring the cost down by 40% or so, according to the best analyses. And so that's going to be a very important way to actually deploy at scale, but at the same time bring the cost down. Seth mentioned a systems engineering approach, which is absolutely crucial to this, because we've got a very complex system here. We've got the various sources of CO2 from energy, industry, the negative emissions technology of BECCS, and the production of hydrogen for the heating sector and maybe the transportation sector. And this has got to be fed into the transport network and then in turn into the storage network. So this is a very complex system that needs to be looked at as a whole to optimize the costs and benefits across the whole value chain. Only by doing that, the whole chain, and can you do that, and to develop transport infrastructure models in a regional context. And the balance of these is going to vary according to regions, so there's no universal model for this. That's why you've got to adopt a systems approach based on your local environment. But you can also use this to optimize how CCS fits into the whole energy landscape as well, and to develop regional models for that. And then finally, we've got essential elements covering policy frameworks and new business models for sharing the risk. So without supportive policy environments, which are stable and long-term, it's going to be very difficult to actually get CCS moving on large scale. So we need to establish effective carbon prices. These may be regional or international, but we've got to minimize the carbon leakage by moving to areas that do not have that cost penalty, if you like. And these need to be sector specific, as they are in Norway, where industrial CCS has a different price from power and heating and so on. And there also needs to be incentives and regulations that encourage investment in CCS. We have contracts for difference that have been used in power for wind and nuclear. What's the equivalent of that? You could use that for CCS. What's the equivalent of that for heating? There's been talk of industrial capture contracts where companies are required to sequester so much of their CO2, and we've talked about tax credits in the States that have been quite successful there. And alongside that, as well as that supportive policy framework, we've got to have business models that actually address the sharing of the risks in the process in an equitable way. So we have risks associated with the anchor project, the main project, behind the firewall, if you like, the factory boundary. We have risks associated with the transport and storage. We have the long-term storage risk as to who will take that on with the CO2 over decades and centuries, and the intra-chain project risks that where one partner in the chains, one stakeholder doesn't have control over other parts of the chain, and therefore there are risks. So we need to have this sharing of risks and balance between business investors and developers and the government, and ways in which this can help are in the transport and storage infrastructure by having publicly funded CO2 transport networks, shared transport and storage infrastructure for multiple CO2 users to use, and then governments taking on the long-term storage risk and liabilities from the storage operators after these have been capped and made secure. So the overall message of this green paper is for policymakers that we have to have, unless there's a market mechanism to monetize CO2, we're going to have enabling and supportive policy frameworks which are stable and long term. And we need to appropriately share the risk between the government and the private sector to facilitate this rapid growth in capacity, and particularly transport infrastructure and long-term storage are key there. For chemical engineers, the key is to establish CCS at commercial scale requires a lot of chemical engineering skills and input. And I think as a profession, we've got a responsibility to make decarbonisation absolutely routine practice in process design and to drive sustainability. And for suppliers of finance, the message is that CCS is a mature technology. It's not a developing technology. There will be longer term technology improvements, but the current technology has risks that are understood and manageable, given an appropriate sharing of those risks between government and the private sectors. So I hope it gives you a flavour of the report, and I look forward to the discussion on it. Thank you.
Thank you, Jeff. So moving swiftly on, we now have a number of publications in response to what Jeff has just presented. And so I'd like to invite Professor Nick Buttler to come and give his publication on the economic challenges of deploying CCS at scale.
Ladies and gentlemen, good evening. It's a great pleasure to be here. It's extremely daunting because I am absolutely not an engineer of any sort, particularly not a chemical engineer. I'm a humble economist, which is of course an oxymoron. I thought the report was very interesting, and I hope that it feeds into the review that the government have now commissioned, which is due to, as I understand it, report in time for the summer and the next stage in the industrial strategy. I start from two positions. First of all, I believe the engineers. I believe that this can be done, that it's technically entirely feasible. And secondly, I believe the climate scientists who say that this needs to be done, that we are heading, despite Paris, for more than 2 degrees warming on the current trajectory, probably towards 3, and that this could be one of the solutions. The only problem, which is where I think any discussion should start, is that this is not being done. All the major oil and gas companies and some of the coal companies, if you go through their public statements on sustainability, they are committed. CCS is part of the solution, but they're not doing it. There are one or two, I think Shell, you mentioned, has one project. A small number of other companies have one project, all at a very early stage. That is not enough. Secondly, governments are not doing it. The European Union created a fund in 2009 to produce, I think it was 9 CCS projects. That money still sits in Brussels, not taken up. I think only one of those projects has got going. And I seem to go to innumerable discussions of what a great thing CCS is and why is it not happening. I think it must be like Moses going back, having delivered the 10 Commandments, coming back and asking why are people still committing adultery when he's told them not to. And I think there are 3 questions, to be provocative. First of all, the paper puts great weight, and quite rightly, on a carbon price. There is no carbon price to speak of that is changing behavior in this country or in Europe, even though Europe is rhetorically very committed on climate change. It is just not happening. My view is it will only happen when we rethink the tax system and make taxation of things that do damage, things we want to change, something that we tax rather than income. And that's a very big change to make, but I don't see it happening just for climate change reasons. If you look at the politics, it's just not there, and I don't believe you can rely on it. Secondly, I think the next challenge is capital costs. The paper has some answers on capital costs, but in my view, not enough to get this breaking into the market. I think it's too reliant on carbon prices, and I think it's also too reliant on this technology being deployed at a scale where you get economies of scale. That seems to me the wrong way around. I think you will only get it deployed in large numbers of plants at a large scale when you've got the cost down first. And I think that is the real challenge for anybody who committed on this and committed on the climate agenda. The costs at the current level are a deterrent, and they're a particular deterrent. I've been looking at energy in India, which I think is the pivotal state when it comes to climate change. India has entered a phase of real growth, 6, 7, 8% a year, and that can continue. And it needs it because there are still 300 million people living in absolute poverty and quite a lot more in pretty close to that. So they need development, they need growth. If you look at the International Energy Agency figures, they're predicting, I think it's 6% growth over the next 20 years. That leads to a doubling of energy demand. Renewables are growing quite rapidly, but if you look at the numbers, that means they grow from 1% of Indian energy demand now to 6% by 2040. And the balance of demand is met by coal. In industry, particularly, but also in heating, coal is there, coal is cheap, coal employs hundreds of thousands of people, and jobs are a key part of the story. And the growth in Indian emissions accounts for all the growth in global emissions over those next 20 years. Many people in Europe are reducing their energy use or reducing emissions in one way or another, and around the world, and the Chinese are making great efforts in the same direction. The Indians are trying, but if you're coming out of poverty, you can't tell people to pay more for their energy. And energy is what they need and use as they come out of poverty. So I think that that's why I come right back, and I'm sorry it's an economic point, without the cost reduction, this won't happen. Thank you.
First of all, I'm just going to ask the panel, once they're settled, if they would like to respond to the points that Nick has just raised.
Not because I'm sitting next to him, but I agree with everything that he said. And I think that this is something that we need to take very, very seriously. Yes, I completely agree with the 3 points, and I will also add some further details to the carbon price. I think that a carbon price could one day reach a level high enough to support a really established carbon capture and storage industry. I think the carbon price is very far from the point the CCS industry will need to get off the ground. That the cost of starting, the cost of putting up the first carbon capture plant in a system that doesn't have the infrastructure is so high that there is no carbon price that could get close to it. However, I think once the system is in place, the price necessary to keep it alive is much more in line with long-term forecast, or at least that best case expectation for a carbon price.
Yes, I think your points are well made. They're points that need to be addressed head on. I think these are not things that all need to be in place at the same time and on the same trajectory, because I think the expectation that we go to instantly have a carbon price that is, say, on the level of Norway's in the across the rest of the world is not going to happen. But it will get there eventually. And I think what we need to look at is how we can actually put carbon capture and storage in place without a carbon price at a cost that is competitive. So it's all relative to what you can do with wind, solar and nuclear. And I think when we're talking about large-scale plants, we're talking about putting them in at the scale that we already have, say, in Sleipner or in Boundary Dam in the States, at the 1 or 2 megatons of CO2 per annum, where the technology is proven at that scale. So what you can do by putting in then multiple plants is that you actually, with the second and third plant, the costs come down significantly from the learnings and the efficiencies that you can get. And what happens at the same time, as that confidence of the investors increases, the cost of capital goes down. So these things together, I think, are an essential route in a non-carbon price world to actually make this happen. And just to give some comparative figures, but I think the estimates when the Oxford report came out a couple of years ago was that against, say, a nuclear price that had been agreed at £80 per megawatt hour, the carbon capture and storage on, say, a gas power plant or, yeah, let's stick to the gas because I think coal will go, is about £110 per megawatt hour. But by the time you got to the third plant, that would come down to about 18 pounds per megawatt hour as well. So it would be on the same level playing field with wind and nuclear. So I think that's the equation we've got to look at. I'm not saying that these are easy challenges to address, but I think we have to bite the bullet and say that if we're going to just tinker around doing small demonstration projects, those will not bring the price down because technology advancement is not fast enough to bring that down on the timescales that we've got to introduce this first wave of CCS projects.
Okay, so we'd like to open that up to the audience for questions, and the audience includes those on the internet. So we have one here from Malcolm at the front, and there's a roaming mic.
Hi, good evening. First of all, let me say, this is a great report. I mean, you've done very well to produce something that hangs together so lucidly. It does summarise all the main problems. I absolutely agree with what Professor Butler said. And that law about underdeveloping countries bursting forward with massive amounts of coal power generation. It's the cheapest way of going, and it's what they're all going to do, which implies that the developed countries have got to move so much faster if we're going to really start to get getting CO2 emissions down. And in that regard, I'm afraid you know, Jeff, I've always been a skeptic, but it's holds up for some time. We're just too late. We are just too late in the developed countries. You know, you talk about 20 CCS plants, 18 of them are on gas treatment plants. Only 2 of them are on power generation plants. These are, and I agree the cost will come down and the next one after value down because the cost went up on value down so much. So I really have, and I think that's not to say that we shouldn't be developing CCS technology, but I think we should, because I think it is going to be necessary ultimately for negative emissions technologies. So I do think we ought to be working at the research level to develop much better capture practices. And I do think there's an opportunity, I think, to deploy it too in other areas of industry. And Stan, of course, has been trying to get something going in the northeast on that, as the Leeds thing too, and the renewable thing. So I do think there's an opportunity there, but we need, for those facilities to go ahead, we need a big concentration of CO2 emitters in a fairly close location. So on the Leeds, have you a question about the Leeds project? Have you done an energy balance on that, on hydrogen production for heating systems?
I haven't personally, but I know people who have, yes.
Does it win or does it lose?
No, I think both in terms of process energetics and the economic model that put in place, I think it's fairly credible with reports that have been done by for both that and the Merseyside project. I don't know, just to make one point there, of course, this learning, cost coming down by learning, doesn't mean that you have to do that in every country. But we use collectively the learnings to actually bring this down. And then as the industry grows, then the developed countries can be exporters of the technology, bringing it into the low cost domain to those countries, particularly India and China's taking a lead on CCS as well, and just introducing an emissions trading system as well. So I think the momentum is there. I think there'll always be skepticism about the speed with which we can get there, and the reason that we're so far behind the curve, if you like, is that the reason for not doing it has always been that we can't do it quick enough.
We have a question at the back there.
Starting as an associate fellow in the institution, former CEO of the North East Process Industry Cluster, and we initiated the Teesside collective project, and indeed we're involved in the Leeds project and one or two others that were mentioned, including one in India. So we've been doing this for 10 years, and I'm really pleased that the report basically confirms what we in North East had concluded, that the technologies were not the issue. But what we have found is the economics, and we come to the kind of conclusion that without complete government funding of the thing, it isn't going to happen. But I do believe that there's an opportunity to focus on both ends of the supply chain. We don't put enough focus onto utilisation of carbon dioxide and getting more processes in place that produce products that will be valued and will therefore pay for the collection of carbon dioxide. And secondly, as a country, we are sitting on one of the biggest coal fields in the world. Don't believe what the Thatcher government said, that we ran out of coal. This is the biggest lie, political lie, that's ever been told. The British Geological Survey shows that we have 10,000 years of annual energy in the Durham coalfield alone. And projects looking at underground coal gasification and dare I say it, capture of the carbon dioxide that's produced will provide our country with not only energy, but the carbon we need for the chemical industry. And what the government don't understand yet is that carbon going into the chemical industry stays and recycles in the chemical industry now. It's clean coal going to the chemical industry. So I think even if we don't take energy out of our coal fields, we should be taking the carbon out of our coal fields for the chemical industry and letting our oil fields die, perhaps with a little bit of help from the carbon dioxide that we might lend them to push their final bits of oil out. But we are a coal country, we have lots of it, and we need to put the effort into establishing clean coal, capturing the carbon dioxide with the technologies that you say we already have, and by the way, using the carbon dioxide to make more products. And I feel that all three of those have to progress at some pace before carbon capture and storage will ever be viable economically.
Does the panel want to respond to that at all?
Very interesting comments. And I think you know, the issue about coal is political rather than resource. And but you know, again, undoubtedly the technology is here to use it if there's the political will to do that. The only comment I'd make, I agree with what you said, but we have to be a bit careful, I think, about, I agree that we should look at utilisation because that is a stream that will add value. Well, let's not get overwhelmed by the scale of that, because if you're putting it into products that permanently take the carbon out of the system, like polymers, polyurethane, for instance, that's fine. But if you're putting them back into fuels, then this is delaying release of CO2 rather than actually contributing to the climate change. So it's part of the equation, but it's a small part of the equation compared with the massive amount we need to store.
Okay, so we have a question from the internet. Ilana.
Thank you very much. For the benefit of people in the room, if we've got quite a lot of questions online, and we've asked the speakers if they will give us written answers to those, if we don't get a chance to ask them all, so you can look at them afterwards. So specifically for Professor Butler, Graham Dawes asked, what return do you think investors may need to be interested in a CCS project? And assuming the cost increases involved with CCS power for an industrial project, what cost, dollars per tonne equivalent, do you think is required as a carbon tax or carbon price to make this happen?
Well, it's a good question which could take a long time to answer, so I'll try and be very brief. I have never seen any study that showed that there would be a material change in behaviour unless carbon prices were at least $50 a tonne. Yeah. And we can debate that, but I'd be very surprised. And this is really changing behaviour both on new investments and coming out of existing investments. And the other part, I'm sorry,
the return that investors would want.
It does depend. The gentleman at the back talked about the public sector investing, which is a nice idea, but there's an awful lot that the public sector is being called on to invest in. So if you're talking about commercial investments for, say, the oil and gas business, they would expect a 15% return on their projects, and if this doesn't meet that, they won't do it, which is what is happening now, actually.
Since the Industrial Revolution, humanity's reliance on the combustion of fossil fuels has led to changes in atmospheric carbon dioxide concentrations. The frequency and intensity of atmospheric ozone and smog, the production of other potent greenhouse gases such as nitrous oxide and methane. Our track record of stewarding the planet on which we live is not just poor, it's abysmal. As the human population has increased, the amount of land needed to house and feed everyone has also increased. To accommodate the increasing population, we've destroyed habitat critical for other plants and animals, leading to reduced populations of birds, fish, mammals, plants, and even insects. As in all ecosystems, many if not all components are connected in one way or another. Therefore, alterations to one component, such as soil quality, can affect other components such as water quality and biodiversity. Mankind's attempts to interfere with the effects of his actions on the natural processes have rarely, if ever, managed to reverse effectively the damage we've done. We can never recreate the animals we've hunted to extinction or replace the landscapes that our insatiable appetite for raw materials have left. According to the Global Footprint Network, humanity's carbon footprint has increased 11-fold since 1961. Reducing humanity's carbon footprint is the most essential step we can take to end overshoot and live within the means of our planet, and CCS is a key element that allows us to maintain something approaching our current standard of living. CCS presents a once-in-a-lifetime opportunity to reverse some of the damage we've caused to the atmosphere. If we mess this one up, we just don't get another chance. And there is every possibility that our grandchildren will be living in a frighteningly different world from the one we have enjoyed. We must get it right, with no unintended consequences, and on a timescale and with a magnitude that halts the slide of this planet into unthinkable chaos. For the UK, we need to demonstrate carbon capture and storage at scale in the 2020s if we're ever going to meet our aspirations in 2050. And I've got 3 suggestions. One is that we utilise existing infrastructure. How can we do that? The Cadent project, utilising the storage in the Liverpool Bay oil fields, is an example of one where we can. There are others out there which, having worked on the Teesside Low Carbon project, I'm well aware of in the northeast of England there. Secondly, I think we need to start making an impact now, not just in electricity. I think there's an overemphasis on electricity. Industrial heat, steel making, and so on, is a big emitter, as we've heard, 20% of the emissions. We can make inroads there. We need to get our socks on and try it. And third, we need to accept that we have reaped the benefits of carbon dioxide at zero cost for most of our lifetimes, the people in this room, and a bit beyond still. And we've now got to pay for it. It wasn't a free gift, it was a loan. And somebody's got to stump up the cash. So I know it's going to cost a bit more. That's fine. What we need to do is face it and get on with it. As they say, bad things happen when good men do nothing. Thank you.
Great, powerful stuff. So any comments from the panel?
I wanted to pick up on your first point about the existing infrastructure, because I think that one of the challenges, especially for countries that do not have an extensive network of pipelines such as the US or Canada, they can exploit as part of the CCS network. I think for these countries that are trying to get into CCS, infrastructure and the shared infrastructure is actually the key challenge. Who pays for it and who takes the risk? So if there is already something in place, I'd say that is the low-hanging fruit that has to be exploited first.
Thank you, and I would agree with that. So the people who've got the infrastructure, the so-called developed countries, are the ones who'd be taking the lead and showing the rest of the world what to do.
Just reinforce what you've said about industrial processes, and we've heard about this already, that this is an area where, unlike power, there are hardly any alternatives. And so I think if the governments across the world show a lead in providing some incentives to decarbonise industrial processes and things like hydrogen production, then I think that's where a lot of the initial progress could be made. I think so as indicated, it's reaching critical mass of these industrial clusters that is the challenge there. Their juxtaposition to appropriate storage sites when we come back to infrastructure again. And I think looking at rather than looking at this as a cost, look at this as what value does CCS bring to decarbonisation of these systems and provision of decarbonisation of heating, which at the moment is some way off, but represents a significant penalty on our CO2 emissions. And so I think the more we can quantify the value that CCS can bring in these situations, the more we will then engage with governments as to what their contribution to enabling that value to be generated, both in terms of value in terms of product, the value in terms of job, and the value to the economy. That I think Nick would be better placed than I am to how you actually put that into the economic scene. But I agree with him that unless we can actually put this in economic terms and what the value is to individual nations and regions, then we're not going to actually get governments on our side to actually provide their share of the taking the risk and providing the infrastructure.
Okay, any questions from the audience? So we have one in the front here, Miles, and then one at the back.
Miles Seaman, Sustainability Subject Group. It strikes me that this whole conversation is a bit like fiddling while the Rome burns. I refer really to Professor Butler's comments about the gravity of this problem, but also it strikes me that the dynamics of finding a solution are incredibly important. Actually, the historical perspective on this is not good. I recall a quite serious government attempt around about 10 years ago to establish a way of establishing a carbon price through personal carbon trading, in fact. And there was, in fact, an Environmental Audit Committee report that actually set out the fact that the situation was very critical now, and if we didn't do something like this, then we were going to be in very bad trouble fairly soon. This is 10 years ago, a report by the government. What I think about this is that we've got to get really serious about the dynamics of the situation and kicking the system very, very hard, so that, for example, a lot of innovation can be brought into the way in which carbon capture is done, and carbon is used as a part of the energy cycle, and indeed whether carbon should be a part of the energy cycle for the medium to long term. But critically, I think the point is that we're wasting our time already. We have been for the last 20 years, actually, and I think we've got to get the message out there that we can do the job if we're invited to, but we can only get invited to do that job if the incentives that are put in place will enable chemical engineering, the chemical industry, process technology, the engineering environment as a whole, and the rest of society to do this quickly. Otherwise, we're lost.
Okay, I think the panel would like to, or Nick would like to respond. Nick Buttler?
Yes, well, I mean, despair is the ultimate blasphemy. And I think you're being a little too negative. I think there's actually quite a lot of interesting things going on across the energy sector. And it's very encouraging to see the falling costs of wind and solar now, led by the Chinese. And I think that will have a big impact worldwide. I think I'm very interested in energy storage, particularly electricity storage. I think the Faraday Institute here is working on some things that could really change the market. And some of the companies are working on things that could link renewables and storage together. So there's a project
of Scotland to pump storage attached to wind turbines. And of course, if you can store the wind that is there, and I think at the moment we get about 2 or 3% of the wind potential. If you could store it, you'd get more of the potential, and you could get away from intermittency, which is a real problem. So overall, I'm not actually a pessimist, but I do think that people rely too much on government. Many of the questions, some of them say government should do this, government should do that. I think the answers will come through science and engineering applied through the private sector. And government has got to enable that to happen, but it can't do it. It doesn't. I've worked in government. I think I was working in Number 10 when the report that you mentioned was published. The government does not have the capacity to take these decisions. It's a follower of what is happening in the world, rather than a leader. It's overstretched, and I think it is for groups like this and people doing research, and then the companies to pick that up. That is where the change will come from.
A quick one.
A quick response to that, Geoff Maitland here. I just wanted to emphasise that I don't think that this is not a competition between CCS and fossil fuels and renewables. That we need as much renewables as quickly and as cheaply as we can get them. What we're talking about here is that all the most reliable projections say that there is this 20% that because of, unless we go back to an agricultural economy and we don't demand energy, that we're going to have to provide using fossil fuels, and we will use the CO2, and we will take the CO2 out. And the second point would be that the reason the cost of wind and solar has come down is not because of free enterprise, it's because governments have put a lot of money in terms of funding the system to bring the price down, and also subsidies to actually get it down to the level it is. And so I think all that's being required here is that governments accept that another part of the energy space that requires assistance in the short to medium term is this CCS sector, and they can do that. If they can't put a carbon price in place, they can actually provide publicly funded infrastructure and risk sharing of the parts of the chain that the stakeholders who generate the CO2 who store it are not prepared to take.
Yes. Okay, so there's a question at the back here in the room.
Yeah, Joe Coleman from Shell, and Geoffrey, you've actually just answered, partly answered my first question, which was to make the point that we have subsidised wind and solar, we in the UK and the Germans as well as the Chinese, but at well over £100 a tonne, in order to, probably closer to £200 a tonne at times, in order to get the cost down. CCS is already being delivered around the world at prices like $70 a tonne. So significantly lower subsidy level is required to get CCS off the ground. But that just reinforces your point. So I'll be rather cheeky and ask a second question. And Geoffrey, you mentioned value and getting value out of CCS. We're starting to see some companies like the RE100 group demanding from industry sort of clean products. So Coca-Cola, for example, wants carbon-free plastic bottles, and they're prepared to pay for this. So is there an angle on this where we could see other companies entering this space and being competitive advantage in having clean products that allows for a price differential on the products themselves and some of the things that are generated through these processes that we're trying to decarbonise?
I'd just like to add to it that the government has hugely sponsored nuclear as well. So that's not a free lunch either.
Just on your second point, I think you're from Shell, aren't you? And your own company has come up with this enormous commitment that by 2040 or 2050 that you will be zero carbon, not only internally as a company, but taking in the umbrella of your users. And that demands that you actually have low
carbon products of the sort that you're talking about. So I think there is this growing momentum of people demanding low and zero carbon products, which gets us back, I think, to this idea that CCS should not just be seen in the context of power, but if you regard it in terms of industrial processes, hydrogen production, cement, iron steel, low carbon products is a very broad spectrum of things, and you can almost have a badging of this, like a safety kite or whatever it is, that products that meet this certain standard could then get a premium. And I think it's very, I'd be interested in Nick's view as to whether how the economics might drive this, because this is adding extra cost to the consumer. So where does public opinion and the balance between that play in the political space?
I just feel the microphone on its way to Nick, because we've been working with the industries in the Liverpool, Manchester area, and as soon as they hear what we're offering, then immediately they want to, generally speaking, they want to be able to badge themselves as being low carbon.
We're short of time. I think the answer is that there are two worlds on this. I suspect in a lot of the developed world now, environmental consumerism is quite strong. People are prepared to pay a bit more for less plastic or for cleaner, organic food, whatever it is. And that has changed the economics. It's a reflection of consumer choice. I am more worried about the countries where people don't have the ability to pay a little more and are right on the edge, and they go for the cheapest. And in many countries in this sector, that still means coal. And I think it will continue to mean coal because I suspect the coal price can go down quite a lot more to keep competitive, even with renewables, given their very low input costs. So it's a bifocal market.
We're running out of time, so I would like one question from the internet, to be fair. So, Alana, is there anything that you could ask us?
Thank you, Steph. I've got a question from Bill Cotton, who's from Johnson Matthey. One of the main issues he identifies with proposed CCS is the capture of CO2 is completed at low pressure and low partial pressure, which means these projects are expensive. What do you think we should be considering what we need to consider is processes where CO2 is captured at high pressure, which is proven on ammonia plants, and it's probably significantly cheaper. Does the panel have any comments on this?
I'll take this one if I may, because this is a live issue for us. We do not think that steam methane reforming with post-combustion capture is the most cost-effective way to deliver CO2 at pressure. And we think that technologies such as autothermal reforming and derivations thereof need to be looked at a lot more seriously than they have been hitherto.
Thank you. So my name is Andrea Demurtas. I'm from the National Audit Office, and I obviously bring a different perspective from the rest of the panel. Definitely a lot less experience in energy and in CCS specifically, but because of the work that I've done on the government program, specifically the second carbon capture and storage competition, I think I can bring some different perspective and hopefully guide the discussion actually on some of the themes that have already been touched before. So for those of you who don't know the National Audit Office, we audit government spending and we support the Parliament to hold government into account. So in 2017, we reported on the second carbon capture competition, as I said, and which means I get the chance to read through documents, official documents, to speak with the government, to speak with various stakeholders. And there are a few lessons that we have identified and that I think could be useful in the perspective of being shared here and definitely be applied abroad. In our report, we conclude essentially that there was a perceived difference in value between stakeholders, especially between Treasury and between the Department for Energy and Climate Change, now replaced by BASE, which includes energy but also industry. At the time that the competition was cancelled, Treasury understood the case for CCS. He understood the benefits, especially on the long term, but he concluded that these benefits were too uncertain, that before they could be achieved, it would require further substantial investment from government, and that the upfront costs were very high. This, in the context of a tight spending review, meant that the competition was cancelled just months before the government was ready to sign the contract or actually start building the plant. I think there are a few points on the background of this decision that we have to keep into account. So the UK program was expensive, but it was expensive because of the way in which it was designed, which is a full capture chain, so from power production until storage. The decision to cancel the competition was taken in the context of the levy control framework being breached. For those of you who don't know it, the levy control framework was a cap on the total cost of policies that could be charged on the energy bill. The carbon capture and storage competition was supposed to fund projects through the energy bills, and this is in this context of this silly being breached, the government decided to cancel it. And the third point is actually more to do with the economics and with the long-term trends. So at the time, and let's say this is still the case, there is a long-term energy outlook is actually a fairly low price. The energy price internationally is low, which translates in essentially in low electricity price. At the same time, you have the cost of other renewable and low carbon generation falling dramatically, and there is also some trend further down the line. For example, batteries, the cost again is decreasing sensibly, and once put together with the cost of solar and wind, could actually overcome some of the shortcomings of these renewable technologies. So essentially, these trends make the case for CCS in the power sector harder. The economies of scale that have to kick in before CCS becomes cost-effective are very high. The payoff is quite down the line. So the government, before it can decide to fund this project, essentially, he has to take a 15, possibly 20 years bet that this technology is going to prove successful and that is going to be cost competitive with these technologies in 20 years' time. Obviously, we know that CCS is a lot more than low carbon power generation. There is a benefit that translates across the sector. For example, industry, as we discussed, CCS is the only way to decarbonize industry. So there is clearly chances there. So let's say 2 points to conclude is, one is how can technical experts assure government that investing in CCS is a safe bet? And when I say investing, this could be simply taking on some of the risk from private investors. And the second point is, in case this plane fails, what is the plan B? So how can we make the case for investing in non-power CCS? How can we make the case to invest in higher cost per ton initiatives such as industry, but which would amount to a lower total bill for the consumer or the taxpayer? This is it.
Okay, some excellent points there. Does the panel want to respond to that? Andy Brown.
Andy Brown. And having worked on the Teesside Low Carbon project, the biggest single risk that we looked at was political risk, which the government would either change its mind or renege on the promises it made to provide the support that it originally offered. We can manage that, then perhaps technology risks can start to be managed.
I just want to comment on, I mean, you can argue many reasons why the competition was cancelled. I'm not going to go down that track, but merely to point out that I think one of the things that currently is needed, both in the UK and elsewhere, is when plants call them demonstration or first phase entry projects, is that they're part of a long-term vision plan of how this is going to come through. And I think one of the problems with the competition was that there was the two projects to build the initial plans, and how this would fit into the economy and grow in the way that we've talked about in the discussion tonight, I don't think has been fully thought through. And you set the challenge of saying that showing the government that this investment is a safe bet. I mean, I think this phenomenon of bringing down the cost by building multiple plants is an initial phase, as I've said, that doesn't need to be done everywhere, that we're done reasonably quickly. And there's plenty of experience in the whole of the process industries across the world that can quantify how much this is going to come down with reasonable expectation and on what time scale. So I think that reassurance can be given, and you have to balance that off against government's view about what they're going to do, about their contribution to the Paris. We heard earlier about the individual commitments to meet the Paris budgets. Just in the UK context, that it's widely accepted by all the experts that we will not beat our fifth carbon budgets unless CCS is in place. So we need that by 2030. And given the project lead times, you need to start building now in order to go through the various licensing signatories and fee processes and build processes to do that. So we need to start from where we want to be in 2030 or 40 and work back. And the answer is you get is that we should have started 10 or 20 years ago.
Okay, so we have a question from the young woman there, and then one at the back, and then one at the front.
Good evening, my name is Maya Lee from Imperial College. So I guess for me, this problem is kind of quite a difficult one. It's multi-sectorial, and also how we value, the service here is quite important. So we're paying money to kind of create this service of like removing CO2, but the benefit is not a monetary benefit. And so how we value the service is quite important. So I attended just a talk just before this one, which was quite interesting from an economist's perspective on how we approach this problem of mitigating climate change. And he kind of thought that maybe we should value the atmosphere as a resource, emitting CO2 into the atmosphere, and this is our resource, the atmosphere, the carbon budget that we have. So we have a set carbon budget, and as we use that carbon budget, we have to pay to have that privilege of emitting CO2. So he kind of looked at the problem from that perspective, and maybe it's how we kind of translate this financial cost to this climate change benefit, how we kind of bridge the gap between those two is quite important. And I guess it'd be nice to hear your perspective on this idea.
Okay, great question. Panel, your views? Who wants to go first? And there you go.
Yes, I can start. I think definitely it's a good argument. It's not easy to price what obviously are externalities, and it's not easy to get those that generate them to pay for them. In some case, actually, it would be counterproductive for the example of industry you would simply risk of carbon leakage. You will risk that the largest emitters will move abroad. I think this is the problem that you pose is actually why policy and political involvement is so important, because that's, government can spend money for not without a clear or immediate monetary return, and it does it every day. Invest in security, invest in health, invest in similar policies that have a certain benefit, but which are simply not quantifiable. So in the case of carbon, there is not only a duty for government to support that, but there is also, as some of the examples made before, there is also an economic gain for the industry that are able to exploit that. So CCS is an industry that can be exported like it was oil and gas. There are value-added products that as well is something that the industry can monetize very well. I suppose there is the issue of bridging the gap between the cost and what is the actual benefit of reducing carbon emissions across the country.
I'm trying to think of the right parallels for this, where people accept the cost of something because they see a greater good. The only one I can think of is defence, but that's not a very, it's not a precise parallel, but I think it does show that the real challenge on this issue is that people have not yet accepted any sense of responsibility for climate change. It's someone else's problem. It's the problem of the future, not now. And while they might want it solved, I think if you look at the opinion polls, they're not prepared to pay much to have it solved. And so they want clean products, but they don't want to pay any more for them. Now, how you get beyond that, I don't know when we will get a breakthrough to real public opinion, even in advanced countries where people have the economic ability to choose. I think it will only come when the problem gets much more serious than it is now, which is fairly depressing, I know. I think then the challenge is, what can you do quickly? I'm afraid we're not there yet, even though, I mean, we think of climate change as this 2 degrees warming by 2100 or whatever. I think it's going to be much more about extreme weather and volatility rather than a smooth path of increasing temperatures. And the political challenge for those who care about it is how you harness the rather soft sympathy on the issue, soft support, and make people accept that they, in some way, are going to pay more, whether it's for CCS or something else. At the moment, they want a cheaper solution, and at the moment, they see renewables as beginning to offer that cheaper solution. I'm not sure that's sufficient, but I think that's where we are.
Yeah, I think that's, you put your finger on the crux of the issue in terms of all these political decisions, is that in democracies they will be delivered essentially by what the public want, because governments respond to a combination of what they think the public should have and what they need. And I think the analogy is a good one with defence, and I often use the fact, that this is a war, it's a chemical war, but the consequences are very long term. The problem with defence spending analogy, of course, is that the timescales are immediate, and we're surrounded by defence threats that the public are willing to actually pay for. So I think the big challenge is how you marshal this growing feeling that there's a problem. The countries that respond, if you take China, it's because they have all these air pollution problems which are related but not directly there, but an enormous amount of low-lying coastline. They're going to be affected by this earlier than I could jump to that. This is why these countries with this enormous carbon emissions are now paying more attention. So it's going to be different solutions locally that capture the attention depending on the form of government and the argument that's made. But I come back to the question that was raised, in your provocation away, how is the government going to put a value in meeting the Paris Agreement targets? What value does it put on? And therefore, given that the private sector cannot bear the costs of everything here, this has got to be a partnership. How do you actually determine what fraction of those costs the government is prepared to bear in order to deliver this value and address these things that are only going to affect our grandchildren or our great-grandchildren? And it takes great politicians to actually say that we must take this as seriously as we in this room, I think, we can.
Very quickly, Nick.
Because I think that absolutely reinforces where I started, which is that you can't rely on the political process. You have to get the costs of this solution so low that it's taken up automatically.
If we can.
So, can we have the question in the back?
Yes, I'm trying to answer the risk question that was raised by the last speaker. I think the problem with carbon capture and storage risk is because our my chemical engineering colleagues tell me that they're good systems engineers, and yet they prefer to work in silos still. Okay? So the general public doesn't get the message yet that recycling plastic has anything to do with carbon dioxide. I'm working in the recovered solvent industry. You try and tell a pharmaceutical company to reuse their recycled solvent. They are too lazy to analyze it and reuse it in their processes. Too lazy. Because what is recovered is 100%, it's not 101%, 99.9%, exactly what they said, what they started with. But they're too lazy to analyze it to make sure that it's pure enough to work in their processes. So for me, the Institution of Chemical Engineers should be looking at the carbon economy in its entirety, because it's a big mess and there's lots of things that can be done that can help towards the reduction of carbon dioxide. But as my good friend John said when he wrote the book, it's like an elephant, and you can only eat it one bite at a time. And I'll tell you a little joke about that later, please. Everybody's ears. But the fact of the matter is, all of these things are connected. We had a question about from our colleague from Shell, which was another one piece of the jigsaw. But the government doesn't see these things as being connected at all. They're working in silos. Oh, how do we pay for that? How do we pay for that? Oh, we're recycling solvents, we're recycling. They don't see that these things are connected at all. And yet this institution, at its core, is about systems engineering, but we don't do it. As a chemist, get out you engineers, leave it to us, lot, we'll sort it out for you.
There's a challenge. Well, we've got a chemical war here, now we've got war with chemists. Any comments on that from the panel? Quick one from Jeff. And then do we want one?
I think you reinforce one of the points of the paper, that a systems approach is essential, but I think you brought out a very important point, that as a communication tool to indicate to policymakers the connectedness that's there, and the potential of actually looking at this more holistically and seeing the opportunities rather than the costs. So when you embed this in the energy system as a whole, rather than looking at just CCS, then you can see what the connections are going to be and how the complementarity of renewables, nuclear, energy efficiency, fuel switching, with what we're talking about tonight, that's got to be addressed holistically together. and the connections made. There was a big communication barrier that I agree we failed enormously at. And I think that's a challenge to take away from this evening.
I'd like a question from the internet, because we're coming to the end of the evening. So let's do that. Alana?
Thank you. We've had a question from Stuart Lodge, comment on the subject of cost. Why does the panel continue to focus on cost reduction if you were going to compare all the CO2 reduction solutions on the same and fair basis? CO2 does not look expensive. For example, when do we compare wind and solar with power storage versus gas power with CCS? Industry, how would electric furnaces powered by wind and power storage compare to furnaces with CCS? The CCS narrative needs to change from one of fair comparison to change to one of fair comparison and one of value.
Panel? Yeah, Nick?
Yeah, I think I can respond to that because when we look at CCS, we actually arrive at a very similar conclusion that different low carbon generation technology, you can compare them up to a certain point, especially when you look at some of the risks that these technologies entail, such as nuclear. When you look at the additional benefit that other technology generates, like CCS. So when you do this type of, and we suggest this type of fair comparison, the CCS is possibly what comes out on top. Again, to come back to what was said before, there is certainly a bit of silo thinking in government when it's looking at this type of problems. But it's also a question of timing. At the moment, cutting emission in the power sector, that's the cheaper option. That is where our cost can be transferred to the consumer in the easiest way. And that is what is done first. On the other hand, in order to realize the other benefits across the economy, that is where still there is no alternative solution, but also the pressure is a lot less. Essentially, there are instruments such as the initial trading schemes that have essentially a pretty negligible effect on the amount of emissions saved. But at the moment, that is kind of perceived as someone else's problem. It's not yet fully internalized, and it's not yet fully, as I said before, taken responsibility for it.
Okay, can we move on? So I'd like the last question, gentleman with the blue tie is going to ask the last question for tonight, and then I'll sum up. Okay, so over to you, sir.
Good evening, Michael Bailey, member of IChemE. It's a question for Andrea, but welcome on the responses. The title that I read here is a chemical engineering perspective on the challenges and opportunities of delivering CCS. And I wonder, do you think that's actually the right question? Much of the discussion I've heard is about mitigation of the potential impacts of climate change. Our colleague mentioned systems engineering. We've talked about competition with alternative technologies. I'm just interested in your different perspective. Are chemical engineers and IChemE discussing the topic in the right way? What's your suggestion for our approach to this?
I think broadly, these are the right topics. These are the RDI level topics that have to be dealt with if we want to bring forward CCS. I think as part of my my short speech, I thought that there is possibly a lack of focus on the industry part of CCS, and this is possibly where the technology is less mature, where the processes are less applied and less understood, and where actually some application can come up as an overall cost to be lower compared to apply to a power station. As far as I can see, government thinking about industrial CCS is a lot less developed than it is for power sector CCS. So that is where I think there is an opportunity for a chemical engineer to present feasible solution that can be applied now and that can get the CCS sector started, maybe on a lower scale, maybe at a very expensive cost per ton, but actually put it into the right trajectory of growth rather than being stuck waiting for a huge multi-billion pounds project to create infrastructure for it.
I think the important thing about this document is, if you want shown in figure 2, it says that the chemical engineers have looked at this subject and they think there is no technological barrier to it taking place. There's already a kit out there that we can point people at that says, there it is, it's working. These are risks we know, these are risks we understand. So the issue isn't with technological risk, it's with political risk and with financial engineering rather than the chemical engineering itself. And in that respect, the document is valuable. I know this would be said, they would say that, wouldn't they? But I don't think the document is written in that way. I think it's written in a more open way than that, and as such I welcome it.
I think it's valuable, and I think it's perfectly legitimate, but I think it's limited. And just as I wouldn't dare to write about carbon capture and storage without bringing in the engineering views that I don't understand because I'm not an engineer, I think it's limiting to write it as chemical engineers without bringing in the commercial and the economic and the political side of it.
Do you want a final comment, Jeff?
I agree that it needs much closer engagement across the spectrum, and we had a certain amount of financial and political input to this through the people that contributed and that they been involved in the competition, so they've been working with the political sector. And I think there's quite a lot of financial expertise on business modelling that's gone into this that isn't, you'll see in some of the references, but you won't see in some of the content of the report. But I would agree that this is a contribution to a debate and an engagement that's got to happen, in my view, not only in this country but across the world, very quickly. And unless we get out of our silos, we get economists like you to help us say, this is the way it looks at the moment, this is the challenge, and we get together to find, well, where are the solutions in this space? But those are the arguments that government has got to be convinced about. And you mentioned there's a process in place in this country at the moment that I haven't been involved in. And so this is valuable input to that, but this has got to be a far, if we're true systems engineers, as Stan was saying, that doesn't limit it to engineers, it limits it to social scientists, politicians and economists as well.
Thank you very much, gentlemen. It's down to me to provide some summaries and closing remarks, although I think you've summarised very well as a panel in those last few points, much of what we've learned today. I think we've been blessed with an excellent panel that has really teased out some of the crucial points arising out of this paper and arising out of the whole debate, and I really appreciate not only your efforts but also the efforts of the audience both here in London and on the ether to debate those points with you. So thanks very much for that. I think the key thing that I'm taking away from this is how much we as a profession and as a community can bring to this whole debate. And I think the Energy Centre itself is struggling at the moment to really come to terms with how we deliver the systems approach. We talk about it a lot, and we talk about that's why we formed the Energy Centre, but we really do need to then deliver that. And I think the issue of that is when you talk about systems, of course, you are involving social scientists and others. So we've made this contribution. We will take further input into it. It's a green paper, as Jeff said, but we need to then work out how best we keep that communication with the policymakers, with the other stakeholders that need to make decisions, and really get something out of this. I think we can show plenty of expertise, but I think we do as an institution actually struggle sometimes to understand, and Andrea has helped us here tonight understand what policymakers need, and so as soon as we understand that, then we can provide more of the information that they're looking for. So that is what the Energy Centre has been set up to do. We're just hiring somebody to in the policy area to help us with that, and being involved with groups like Future Climate Engineering Solutions, working very closely with BEIS is another way we're doing it. So I think that's the lesson I've learned tonight, is that communication, really delivering what the politicians and the policymakers need from us to be able to make those decisions, and to convince the public that that's the best way forward. So, so thanks very much, gentlemen. Can we thank them in the usual way?